Good morning. In this video, we are going to discuss about the moment of inertia of a rectangular lamina. So here is the rectangular lamina. Of width B and height equal to D. In derivation, first we are going to find the moment of inertia about the base axis. Then we are going to find the moment of inertia about centroidal axis. Base axis is simple Cartesian coordinate where O is the origin and this is the x-axis and this is the y-axis. Now let us go to the derivation. Area moment of inertia with respect to x-axis is equal to integration of y square dA. So already we discussed this formula. Now dA is nothing but a small element being taken like this, which is parallel to x-axis. The distance between dA and x-axis is y, where y varies from 0 to d. 0 is the lower limit and d is the upper limit. D is nothing but the height of the rectangle. So this is what here it is written. Limit starts from 0 to d. Now the second one is the dA, area of the small element. So this is the small element. Now the width of the small element is equal to again b, okay, and height is equal to dy, okay. Since it is parallel to y-axis, here it is taken as dy. Now area equal to b into dy because it is a rectangle. Now I am going to substitute both dA and limit into this above equation. So it becomes like integration of 0 to d y square b into dy. This is a constant, so can be taken out. Now again this equation becomes like 0 to d y square dy. Integrate and substitute the upper limit and the lower limit. Finally we will arrive this equation as b d cube by 3, okay. Similarly we can get the answer for the moment of inertia about y-axis, which is equal to db cube by 3. These two are the moment of inertia with respect to base axis. Now let us find the moment of inertia about the centroidal axis. First we will discuss the position of the centroidal axis. Here this is the rectangle. This is the position of the centroid, okay. In centroidal axis, the centroid will become the origin. Now this is the centroidal x-axis and this is the centroidal y-axis, okay. Centroidal x-axis is located from base axis by the distance of y bar. This is equal to y bar, okay, where y bar equal to d by 2. Similarly, this y-axis is located from the base axis by x bar. So here is the base y-axis, this is centroidal y-axis. Distance between these two is x bar, which is equal to b by 2. B is the width of the rectangle. Now let us go to the derivation by using parallel axis theorem. This is the parallel axis theorem. It says that this is the moment of inertia about base axis, this is moment of inertia about centroidal axis plus area of the rectangle into d square, where d is nothing but distance between base axis and centroidal axis. And I want to know only the moment of inertia about centroidal axis, so this is taking in the left hand side. Now the above equation will be rearranged as iox minus a d square. Now iox already we derived, so here is the answer b d cube by 3, and a is nothing but area of the rectangle b into d, and d is again which is equal to y bar, distance between ox and gx axis, d equal to d by 2. And after substituting these three values into this equation, it will become something like this, b d cube by 3 minus b d into d by to the whole square, and simplification of this equation will be like b t cube by 12, okay. So this is the moment of inertia about the centroidal x-axis, b d cube by 12. Similarly, the moment of inertia with respect to centroidal y-axis is db cube by 12, okay. These two are very important equations because if we know the moment of inertia about centroidal axis, then we can find the moment of inertia about any parallel axis. You see parallel axis there, this is very important. So normally it is my advice to find the moment of inertia about centroidal axis only, which is constant. Thank you. We will meet in the next video where we are going to find the moment of inertia about a triangular lamina. Thank you.